Hello, this is Clayton Balmas. I'm your teacher today here in our audio classroom with SynMax.University here at SynMax Performance Lubricants. And we're at part 3 of our racing and commercial coolant system. And this is section B of part 3, which is coolant system cleanliness. So I hope you enjoy listening to this as much as I do sharing it with you. And let's go for a ride. Okay. Cleanliness, radiator versus engine. Now, here's a good one for you. See, here's the deal. Radiator manufacturers, when they provide a radiator to you, it's going to be surgically clean product that no matter the application, we're just telling you, it's all basic. You got cooling tubes and tanks mathematically designed for the BTUs that it has to transfer in heat for the engine and vehicle size and design and application. Now, loss of radiator performance and heat transfer effectiveness will come from the outside contaminants. In other words, what's going to dirty it from the outside or dirty it from the inside? You see, contaminants coming from either the coolant fluid used, which is the water, the antifreeze, or the chemical additive package, or the mineral water, or the hard water, whatever you got, and the engine coolant surfaces, in other words, the rust coming off the engine or the corrosion coming off the engine, will become entrapped in the radiator, attaching to the coolant tubes and tank surfaces. Well, how do they become entrapped? Well, it's really simple. When the heated surfaces become hot, the pores expand. I call it a micron metal pore, right? And it's got one out of two things. When it cools off, it can either grab onto, it goes open up, and then it can either grab onto the chemical treatment to protect it, or it can grab onto the rust and the contaminants and the minerals and all the junk and the calcium from the salts and blah, 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 and really mess it up. Okay? Because here's the deal. When you've got, let's say, even a 1/16 of an inch of contamination inside that cooling tube, it will reduce your radiator efficiency about 30 to 40%. That's a historical fact. But anyway, we have to have steps with focused effort that need to be taken for the engine and fluid contaminants to be stopped. In other words, we don't need that stuff in our neighborhood, okay? To be prevented before they even begin to be flooded into the radiator. Since radiator cleanliness is not the issue, in other words, when you get it from the factory, we need to work with the engine builder and or customer to stop the contamination before it even happens, to provide long-term coolant performance repeatability. In other words, if you got a brand new radiator and everything, and when you're starting the racing season out in, let's say, April, in short track, whatever, in April, all right, when it becomes August, September, we need that same efficiency you started out with. We don't need, when the championship happens in September and October, for all the muck to get in the radiator at the hottest point of the season. Now, that doesn't make sense. We need repeatability every time. When you start that car to the end of the race, from lap 1 to lap 200 or whatever, you're going to have repeatability, and that's what we're here to do. Now, here's the deal. The problem is that unless the engine builder at the time of manufacturing or at the dyno session can use a surface protection chemistry for the steel and the aluminum, the engine surfaces will begin to corrode or oxidize, all right, rust or aluminum. These contaminants then get flushed and trapped into the new radiator when you bolt it in the car and you fire it up. Historically, the new engine surface contaminants immediately affect radiator and coolant system heat transfer efficiency, by 2%. Hey, it's a percentage. This contamination issue can be avoided when to be protected, all right, is when you put in an advanced water coolant system chemistry at the time of the dyno session. In other words, stop the problem before it even begins. Now, the water cooler technology has such a chemistry. It will protect the engine surfaces. You see, there's a protection for either the steel or the aluminum. So even if the air tries to hit the surface to create that rust or that corrosion from the aluminum, all right, the chemistry will embed into that surface, and it will not allow the air to create the surface contamination. Make sense? So you can transport it to the customer, and it'll be nice and clean with no caffeine. So if the customer radiator and engine already has surface contamination, it really needs to be cleansed and eliminated for proper system performance. Now, SynMax coming up has a bioenvironmental safe coolant system cleansing technology. It's called rust dissolve because you have one chemistry for the iron and then alumazole, which is the other chemistry for the aluminum. And it can be used in the engine after it's been installed in the car to be able to flush the system and to gently cleanse it. And it's environmentally safe. So we've got a presentation available to talk about that. Okay. Now, what happens is that we have to have metal surface cleanliness and metal surface protection. You see, metal surfaces at the micron metal pores open and closes, with a temperature exchange. All right. I call it like a micron metal sponge. When it's hot, it's open. When it's cool, it closes. Then the microcontamination, which is the minerals from the water, rust from the engine, whatever, will flow into the radiator, cooling tubes, and tank walls, as we mentioned. Then the radiator aluminum metal surfaces over time, they're going to grab the contaminants and just hold on to the metal. And once they're in there, you're screwed unless you can boil them out, all right? But unless cleansed, as I mentioned before, these contaminants will create a micro insulation film upon the metal surfaces. These mineral insulation will produce radiator heat exchanger performance or heat transfer performance. About a 32nd of an inch is 20% reduction, and a 16th of an inch is 40%. The answer is this. With an advanced surface coating protection chemistry technology, which will both coat the micron metal surfaces with a non-metal inhibitor, which forms a film on the metal surface, it will also reduce the surface tension and friction for the water to flow easily. Now, here's the deal, and this is what we experience. We'll show you a picture that if the chemistry is upon the metal, it will flow really easy past it. So you want to be able to have that. Further, it will keep a clean metal surface barrier for heat to be effectively transferred to the metal surface. In other words, like we talked before about heat energy, for repeatable life cycle performance. Now, we have to have scale deposit protection. Hello. This is formed because regular tap water contains various levels of calcium and magnesium salts. We talked about that in the other presentation. At 100, as stated previously, salts are suspended within cool water and they stay dissolved. All right, calciums and all these others. And then at temperatures of 125 degrees, the salts are released. When cooled, they remain to form a surface scale deposit. All right. Again, the problem that the surface scale deposit will prevent a heat transfer. As mentioned before, these scale deposits and minerals are going to greatly affect and reduce the heat transfer capability performance as much as 40%. As mentioned, premium chemical science and technology will treat the water and coat the metal surface to prevent and gradually remove the formation of the current and in the future scale deposits. All right, but the chemistry can only clean a little bit, but we have to stop the situation before it happens. If we want to cleanse it, we got to use like the rust dissolve or alumazole. But the products such as water cooler, it'll do better, but it's hard to fight with one arm tied behind your back, right? We have to look out for corrosion protection and the aluminium. You see, aluminium has naturally electrical properties within it. All right, it's even higher than zinc. Aluminium is an electroactive metal, and it requires an impenetrable film to protect rapid corrosion. Now, before we used to use a lot of zinc coatings, okay, for the aluminum and the solder. But under recent conditions, a lot of that has been really stepped back because of the environment. Okay, and this coating prevents the attack of acids. All right, modern automotive engines, they use aluminum for heads, radiators, water pumps, and everything. So they require significant greater corrosion protection than their cast iron counterparts. What we have to do is help coat and protect against corrosion and allowing scale deposits to form, right? Because if you don't have this, it causes a degradation of the cooling system walls, components, the water pump, weakening of the head gasket, mating surface areas. Corrosion will produce increased scale deposits in the lower temperature surface areas. Okay, like if you've got a radiator or whatever, you know, um, if it's hot, the pores can open up and the water goes past and it flushes. But in the lower radiator or the lower engine areas, if you've got an aluminum engine where it's cooler, it's just going to grab onto it and hold it. It's just not going to open and release it. So you might say, well, how can you show me what the difference is with the chemical technology? All right. Well, we're going to show that because we want to keep that aluminum as clean as possible for increased heat transfer efficiency. Cleanliness is so important. So let's have a look at this. The following is a race and radiator picture presentation. So what it was is we had a couple of guys on our in our group. They put about 1,000 miles on both of them. And then they had an accident. And I said, hey, can we have your radiators, for an inspection? Kind of like a CSI for radiators. And I want you to see what happened here. Now, on the top, we had a fluidine radiator. And you can see on there, the coating that you see was actually the chemistry coating in the fluidine radiator. All right. It could have been a CNR radiator, could have been a Griffin, but this was a fluidine. So we cut through the tubes. You can see how clean it is. I mean, you literally can take your finger and just wipe that off. And you know what that was? That was the actual chemistry coating on there from the aluminum chemistry. You can see that this radiator looked like brand new. Now we had another radiator. It was a very heavy duty one, you can see here. And I don't know who the manufacturer was on this one. And you can see in the oil tube cooling area on the hot spot, it just grabbed all the contaminants that were in there. And then inside the tubes, you could just see all the minerals that just got attacked on there. So common sense tell you, and here we got a side-by-side between the fluidine and the other radiator. If you're radiator A, guess what? You've got 30% reduced heat transfer efficiency. If you're radiator B on the right, which is the fluidine, okay, don't you think when the metal gets onto that surface, it'll transfer the heat better? Something to think about. So in our next presentation, we're going to talk about electrolysis, and we're going to talk about the effects of electrolysis on the component's performance. So in summary, for water and system cleanliness, you require an advanced chemistry found within the SynMax water cooler products. So one of the resolutions for this is we've got our SynMax water cooler system treatment. This here is the concentrate, and inside you'll be able to have all the chemistries that you need. You need to mix this with purified water, or if you've got a 50-50 glycol in your antifreeze, that's great. Or if in your racing system, you got the good 7.0 water, you can mix it right straight in, and you'll have all the advanced scientific formulation additives that you need. Here we are at the end of our presentation of the water and coolant system cleanliness, part 3. Now I encourage you to look at our other presentations that we have on the coolant system, available on the internet and the web. Our desire is just to get you thinking with another option of consideration to take it up to the next level. So again, the water needs to be purified. Let's start clean without the minerals getting in there. Let's maintain coolant system cleanliness so that we can have optimum heat transfer, and system surface protection. Isn't that a good deal? So, we encourage you again to look at our other presentations and information. And this is Clayton Balmas here with SynMax University here at synmaxperformancelubricants.com.